Again, thank you guys so much. Lorraine gave a very kind introduction. I am recently board certified by the American Board of Lifestyle Medicine. Who knows what that is? It's a pretty new field. Anybody have any clue what lifestyle medicine is? Let's talk about it just a little bit. So lifestyle medicine looks at 6 pillars, and there's 6 things that really help you to live a wholesome life and lower your risk of chronic diseases. So the pillars here are nutrition, primarily plant-based nutrition, exercise, so staying active, avoiding tobacco, alcohol, stress management is a huge one, sleep management is another huge one that is really underrepresented in medicine today, and healthy relationships. So all these things help us to decrease the risk of chronic diseases, help us to decrease risk of things like heart disease, cancer, etc. So what can lifestyle medicine do for you? How powerful is lifestyle medicine? Well, you can decrease heart disease by 80% at least. You can decrease and improve diabetes by 90%. You can decrease cancer by 60%. And what is so empowering about lifestyle medicine? Well, it's not really what I can do as a healthcare provider, it's what you can do. It's all about you. So this is me in my daily job. I'm a surgeon, right? I love to do surgery. That's why I became a surgeon. So what am I doing here in this field of lifestyle medicine? Why did I go back to school and sit for another board exam to be lifestyle medicine certified? What is it about lifestyle medicine that is so intriguing? Well, it all comes back to the day that I graduated medical school. We took a Hippocratic oath. And this oath essentially says, first do no harm. That's huge. To me, if we can prevent a lot of these chronic diseases ahead of time, we are doing no harm. There's no such thing as a surgery without a risk, right? Why not avoid the surgery in the first place? Make sense? Okay, so here's what we're going to talk about today. We're going to talk about cancer. We're going to talk about the leading causes of death. We're going to talk about the hallmarks of cancer. What makes a cancer cell unique? We're going to talk about how to feed your cancer. And then we're going to talk about how to starve your cancer. All in that order. Cancer is one of those things. All of us, I can bet, if I asked you if you personally or knew somebody close to you that was touched by cancer, your hand would go up, right? It's a very, very common thing. And it's something that, for the large part, a big part of it can be preventable. So before we get started, a couple of things. A disclaimer, you always want to just check with your doctor so that you can come up with a plan that's right for you. And if your doctor doesn't like your plan, find a new doctor, okay? The next thing, I live on Maui and I do have a flight to catch, so we're going to try to limit questions at the end. Please feel free to email me with any personal questions you have and I'll get back to you for sure. And then the last thing, please stand, move around. You heard sitting is the new smoking, right? I love it if you guys get up, move around, jump around, please do that. Okay, so quiz time. Leading causes of death in the United States. Who knows number 1? You guys are good. Okay, how about number 2? Cancer. What about 3? This one's a little tricky. Yeah. Accidents, good. So accidents, everything lumped in accidents, we're looking at opioid overdosing, which is a huge problem and addiction, suicides, iatrogenic, so hospital problems with medications, etc. That's number 3, which is not insignificant. Last year, over 1.7 million Americans were diagnosed with cancer. That's a lot. How does that compare worldwide? Well, in the world, there were 9.6 million cancer deaths in 2018. Experts estimate 6 million people died in the Holocaust, yet we have over 9 million deaths in 1 year. Why are we doing nothing about this? And it's expected to double by 2030. So let's look at what's expected for this year. What can we look forward to as Americans in 2019? Well, 1.7 million new cases are expected to be diagnosed. 606,000 Americans are expected to die from cancer in 2019. Compare that to the leading cause of death, heart disease, 640,000. So very close. They're neck and neck for number one. That's 1,630 lives every day taken by cancer. And it's already the leading cause of death in 22 states. Compare that to 2000, only 2 states had cancer as the leading cause of death. Any idea which states those were? Alaska and Minnesota. So in 2019, what do we estimate for types of cancer that are going to be diagnosed? Well, prostate in men, most common cancer. Lung cancer is number 2, and then colon cancer is number 3. When we look at females, it's a similar picture. So breast cancer, number 1, it's a hormone-dependent breast cancer. We have lung cancer, and we have colon cancer. These are things that have been diagnosed. I'm going to take a step back and talk to you about diagnosis. To have a diagnosis is a major thing. What about all these cancers that are not diagnosed? We know that there's cancer cells circulating throughout our bodies, and we're not diagnosed with cancer. They're circulating at any given time. So what changes when they become clinically a problem or significant? Let's take breast cancer, for example. Breast cancer is close to me. I treat a lot of breast cancer. There was a study that was done. They looked at 110 women from the ages of 20 to 54 that had died in car accidents. Non-cancer related causes. They did autopsies of these women. Only one of them knew she had breast cancer at the time of her death. How many people do you think they found breast cancer on in these autopsies? 20%. Good guess, thank you. Yeah, so 20% had cancer that they didn't know about that was diagnosed on their autopsy. That's interesting. Well, of those 20% of women, 41% had cancer in both breasts. Whoa, that's huge, right? We call this a clinically occult malignancy. This is something that was there, that was not clinically significant. It wasn't changing our life in any way, but it was very present. So the question becomes, when we're dealing with cancer, is that maybe there are some cancers, especially cancers in situ for breast cancer, that are clinically silent for years, or they regress. They're never really a problem. Maybe we should think about, in these cases, dying with your cancer instead of dying from your cancer. Does that make sense? We may have cancer cells in our body, but they may never cause a problem for most of our lives. That's where we would like it to be. Anybody have a calculator? We all have them on our phones, but I just want to prove a point. So I have a question for you. How many cancer cells do you guys think are in a 1 centimeter square tumor? 1 centimeter square, weighs about 1 gram. So that's about the weight of a dollar bill or a paper clip. What did you say? 1 billion, what a good guess. Yeah, so 1 billion cells. Good job. So when we look at cancer cells, let's say we have 1 cancer cell and it divides, you're going to go to 2 cancer cells. And then those divide into 4 cancer cells, and those divide 4 times again, and so on and so forth. How many divisions do you think it takes to get to 1 billion cells? It's 30. Only 30 divisions. So when we are looking at cancer, it all depends on how fast our cells divide. Are they aggressive or are they not? If they divide multiple times very quickly, you could have an issue. If they divide very slowly, it may not be something to worry about. So breast cancer, for example, cells can divide on an average of every 25 days to every 1,000 plus days. So you could develop a problem with breast cancer in a few years or 100 years. It all depends on what environment these cancer cells are in. How fast are they dividing? How aggressive are they? So again, the goal would be to try to manage the cancer, if you'll accept that term, rather than let it manage you. One caveat about diagnosis. If If you look at this slide, we are looking at men in the US, and we're looking at rates of cancer diagnosis. You can see that golden line on the top, that's prostate cancer. See that huge spike? Big spike in diagnosis. Anybody know what that's from? Good. So that is PSA testing. So essentially, the medical community decided to change what is the diagnosis of prostate cancer. And they started to test PSAs, do more biopsies, therefore we had more cancer. Did that really cause a change in these men and their lifespan? No. These men lived a long time with these cancers for the most part. And you can see, if you look at that golden line there, it goes down again. And that's because the medical community said, whoa, maybe we're overdoing it on the PSA. Maybe we should back off because it's not a clinical problem. So what is cancer anyways? What makes a cancer cell a cancer cell? It's kind of a complicated question, huh? This is a complex graph, but these are the hallmarks of cancer. So these are what cancer cells that are unique compared to every other cell in our body. Well, one obvious thing is they have something called immortality. They don't die. They just replicate and replicate and replicate without any issues. And then the red box there, they have something called angiogenesis. Anybody heard that term before? So angiogenesis is where cancer cells can actually send signals to create new blood flow, to come and give them more blood so the tumor can get bigger faster. So they induce angiogenesis. Other things that they can do, they're very aggressive, so they can actually metastasize. They can spread to other places. They can invade other cells. And then they can evade growth suppressors, meaning anything that our body tells a cell to stop growing, hey, you're out of bounds, stop growing, they ignore all those signals. That's what's unique to cancer. This next one's even a little more complicated, but I want to show you just to demonstrate. There's all these different targets to treat cancer, tons of them. There are drugs that treat this, there are vegetables that treat this, there are all sorts of things that will target different parts of cancer cells. All right, so quiz time again. Let's talk about cancer. How many cancer cases do you guys think are genetic, that you inherited? Good. A+. All right, so how about sporadic mutations or due to lifestyle? I think we can all do math, right? So 90 to 95%. That's huge, huge, and it should be encouraging for all of us in this room. So when we look at cancer, let's just talk really quick about processes that contribute to cancer and then chemopreventive agents. So chemopreventive is a word for drugs or compounds or agents that prevent cancer. So processes that contribute to cancer, well, we know inflammation contributes to cancer with that up arrow. Chronic low-grade inflammation contributes to cancer. On the flip side, we know that certain chemopreventative agents can decrease inflammation, and that's going to decrease your risk of cancer. Reactive oxygen species. Have you guys heard of that term before? How about free radicals? Okay, so that's all the same. So you have a metabolic process in your body that can create reactive oxygen species or free radicals. And those free radicals, if you think of the word, they're named that way for a reason. They wreak havoc, and they will cause cells to mutate into cancer cells. Apoptosis is another important one. Apoptosis, you guys heard that one? So apoptosis means programmed cell death. Normal cells in our body, as we divide, as they get older, they get a signal in their DNA that says, you need to die now, time to die, and they do. It's suicide. Cancer cells do not have that, so they have decreased apoptosis. And then the last is cell migration. Cancer cells can migrate. They can go to other places. They can metastasize. And that is a hallmark of cancer as well. So let's talk about lifestyle factors that cause cancer. Anybody know the #1 cancer-causing lifestyle factor? Did I hear tobacco? Yeah, that's the #1. How about #2? Diet. There's a big one. And then we have other stuff. I bet most of you didn't know that infections are the third leading cause of cancer in the world. There are infections, a bacteria called H. pylori that can cause stomach cancer. There are other, HPV virus can cause certain types of cancer. It's a big problem. Then we've got alcohol use. We have physical inactivity. We have obesity, which is a huge contributor to cancer, and we're going to talk about all these individually. We have sun exposure, so ultraviolet radiation can cause certain types of skin cancer. Environmental pollutants is the last one, so what we're exposed to in the environment. Out of all of those, the top three we talked about, tobacco, diet, and infections, those account for the vast majority. Tobacco, you're looking at 25 to 30% of all cancers caused by tobacco. Diet, ooh, this one's huge, 30 to 35%. And then we have infections, which is large at 15 to 20%. So when we're looking at a complicated graph like this, you can see on the top pie chart, the green, the environment, is responsible for the majority of new cancer cases. That small little sliver, genetics, you can see on the left that there's some cancers there that are mostly attributable to genetics. And most of those are rarer cancers like testicular, thyroid, etc. On the environmental portion, diet, tobacco, infections, as we talked about, responsible for the lion's share of cancers. These I'm going to go through super fast, and then we'll get on to the interesting stuff. Genetic cancers, I just wanted to illustrate that there's a lot of genetic mutations that are associated with certain types of cancers, and we're discovering more and more of these every day. Alcohol, again, responsible for cancers, but on the bottom half of that circle, you see that smoking can cause multiple types of cancer. When we look at diet, diet has been associated with all of these cancers: pancreatic cancer, colorectal cancer, lung cancer, breast cancer, multiple types. And the science behind this is pretty robust. On a related tangent, obesity, same thing. These are all the cancers that have been attributed to obesity. Quite staggering. And then lastly, the infection, like we talked about. HPV is a huge problem, a virus that can cause cancers. Epstein-Barr virus can cause lymphoma. You can have all sorts of viruses that can cause cancers. So off to the good stuff, how to feed your cancer. So forgive my sarcasm for a moment, but I'm going to go into a mode of what can we do to best feed our cancer? How can we act to create a pro-cancer environment? Well, number one, smoking. Smoking is excellent for developing cancer. Number one cancer causer, correct? And diet as well. So what you eat, you can really get your cancer growing and dividing cells like gangbusters. Alcohol use, you want to make sure that you drink a lot of alcohol if you want to feed your cancer. You want to particularly have hard liquor and multiple times throughout the day. Physical inactivity, make sure you are sitting on a couch, lying down on a couch, not getting up only for very limited things. The thing is when you're physically inactive, you also become obese, which can feed your cancer too. And then the last is you want to make sure you're exposed to as many environmental pollutants as you can. That'll set you up for the best cancer possible. All right, so let's talk about this in detail. Tobacco. We already talked about the fact it's the number one cause of cancer worldwide. Kills over 6 million people in the world every year, tobacco does. There's over 7,000 chemicals in each cigarette. Over 250 of them are known carcinogens and known harmful. Moving on to alcohol very briefly. It's associated with many cancers, the esophagus and the head and neck, mouth and throat most common. What's interesting about alcohol intake is when it is compounded with smoking, when those two go together, it's exponential, meaning that you're getting much more toxicity from your alcohol and from your tobacco. Obesity is the next one. So 2 out of 3 Americans are overweight. Have you guys heard of body mass index? So body mass index is a pretty crude way of measuring how large you are, how obese you are. We know that people that have a lower body mass index have lower cancer rates. And what else is super interesting is there was a study of people looking at what they ate in their body mass index. You can see that eating meat is clearly the best thing you want to do if you want a high body mass index. If you want to be a very skinny person, low body mass index, low cancer risk, the vegans win on that one every time. Okay, so here's some really cool stuff I can't wait to talk with you about. IGF-1, insulin-like growth factor 1. Who's heard of that? Okay, so a few people. It's very, very cool stuff. So insulin-like growth factor 1, this is actually a model of its molecular structure. It's a hormone. It's similar to insulin. It's vital to childhood growth. You have to have this hormone in order to develop normally when you're a child. It's present in breast milk, which is the highest source for us. It's also present in things like cow's milk, dairy, meat, etc. What's interesting is that as we go through our life, if this hormone is too high, it can cause mutations and can cause cancer. So we know that IGF-1 promotes stages of cancer development. It promotes cell growth. It promotes that vascularization, that fancy word apoptosis that we talked about. Promotes all these blood cells to come and help the tumor grow. It promotes metastasis, and then it prevents apoptosis, so it prevents programmed cell death. This is an interesting story. These are people called the Lerone people. Who's heard of the Lerone people? They're people, they live in South America. They were discovered for the most part by Walter Longo, who's this guy in the back in the black hair. And what he found is all these people, they didn't grow to be full height. They had a genetic mutation where they could not process IGF-1. They didn't make it. So they had no IGF-1. They were very, very short people. But what intrigued Dr. Longo is he found that these people, none of them developed cancer. None of them. No IGF-1, and none of them had cancer. So how does that work? If you're looking at physiology, we have the pituitary gland that secretes growth hormone that then goes processed by the liver and creates IGF-1. But in Lerone syndrome, you don't have the feedback, so you never create that IGF-1. Sure, they have a tiny little bit, but they don't have much. So what happens the opposite of Lerone syndrome? What happens when we have way, way, way too much IGF-1? Something called acromegaly. So Andre the Giant's a really good example of this. He had acromegaly. He was a very, very tall guy. Unfortunately, people that have acromegaly also tend to have higher rates of cancers. Interesting. They have too much IGF-1. So when you look again from a molecular standpoint, you get a lot of growth hormone with acromegaly, and that translates to IGF-1. So let's talk a little bit about the science of IGF-1. We know that high levels of circulating IGF-1 is associated with cancers. This large paper tells us just that. It's associated with these types of cancers. So prostate, breast, colon cancer, lung cancer. More studies show us other things. Again, the breast, prostate, colon, and lung. But what's interesting is this next study. Scientists looked at caloric restriction. So basically, how many calories are we getting per day, and cancer rates and IGF-1. Well, they found that caloric restriction decreases IGF-1. So caloric restriction, best way for caloric restriction, fasting, right? So fasting can decrease IGF-1, but also being vegan, particularly plant-based diet, is essentially a form of caloric restriction. You're eating much less calories than everyone else, therefore, you're having lower IGF-1 levels. So what are some foods that raise IGF-1? The standard American diet, we'll talk about that more in a second. Sugar, milk, dairy products, and then high protein foods can raise your IGF-1. Another study looked at a whole bunch of people, meat eaters, vegetarians, vegans. They found that vegans had the lowest IGF-1 levels, so it's correlated with science. Followed by vegetarians, and of course the meat eaters had the highest IGF-1 levels. So let's talk about ultra-processed foods for a second. cancer-causing chemicals. What comes to mind when you think of ultra-processed foods? Spam is good, very good. Yeah, so things that come in packages, right? So sugar drinks, donuts, bacon, everything that you see on that picture is an ultra-processed food. All of these foods we call ultra-processed. And what exactly are they? Well, you can see the majority of them sugary products. So sugar is added to things you wouldn't even think it would be added to. Ketchup, for example, stuff like that, right? That's an ultra-processed food. Drinks, starchy foods, breakfast cereals, that type of stuff. Well, scientists looked at ultra-processed foods and cancer rate, and they found that people that had a longer time where they ate ultra-processed foods, they had a higher risk of cancer. That paper was published in the British Medical Journal in 2018. So let's move on. How to feed your cancer red meat. I'm going to focus on red meat because that's where a lot of our evidence is the strongest. When we eat red meat, we have changes in the composition of the red meat due to cooking, for the large part. There's a high temperature and it creates carcinogenic molecules. And all of these compounds we're going to talk about individually. But we have N-nitrosyl compounds, heterocyclic aromatic amines, polycyclic aromatic hydrocarbons, heme iron, and advanced glycation end products, or H. Baking, roasting, barbecuing, grilling, pan frying, it exposes these meats to high temperatures. And that's how we get a lot of these compounds. So heme iron. Our body has two types of iron that we like, heme iron and non-heme iron. We know the heme iron comes from animal sources, and the heme iron is more efficiently absorbed into our bloodstream. But we also know that it's particularly the heme iron that's linked to cancers, especially colorectal cancer. And how does this happen? Well, it forms N-nitrosyl compounds. One thing I do want to touch on here is I do love vegetarian options. However, have you guys heard of the Impossible Burger? So the Impossible Burger is made from heme iron. That is their claim to fame. They're adding heme iron to try to make it more like a real meat burger. There's no science behind this, but I have concerns because we know that heme iron is directly carcinogenic. So that may not be the best veggie burger choice. Okay, so N-nitrosyl compounds. We have processed meats. In processed meats, they add nitrates, they add nitrites. They also form from protein and lipid degradation. This was a study, it was done in 2003, and it was a randomized controlled trial. And they found that if you had a group of people that ate low red meat, high red meat, or vegetarian, they could measure N-nitrosyl compounds in the blood. And they found, of course, that the people that ate the high amounts of red meat had high N-nitrosyl compounds in their blood. But what was interesting is when they took these people and they supplemented them with 8 grams of heme iron, they had high nitrosyl compound levels. But when they supplemented with non-heme iron, they had normal N-nitrosyl compound levels. So that tells us it's isolating it to the fact that this is heme iron that is the problem. Another study looked at people that ate a high red meat diet for 8 days, and then they had it followed by a combination of red meat and fish for 8 days, and then 8 days of high fish. But they essentially, again, prove the point. There's higher N-nitrosyl compound formation with red meat diet. Another study, again, showing the more red meat you eat, the more N-nitrosyl compounds, the more DNA damage. So what foods are the highest in N-nitrosyl compounds? Any clue? So we're looking at processed meat mostly. Bacon, fried bacon is the highest, the number 1. And then we're looking at cured meat, smoked meat, sausages, salami, bologna, that type of stuff. So let's talk about another one. Polycyclic aromatic hydrocarbons, PAH. The main source again is meat. It's formed by contact between fat and flame. So when the fat from the meat comes in contact with the flame, it creates this chemical. And it's more common in grilled meat. And you can see here on the left there is benzopyrene. That's a class 1 carcinogen. We're almost through all these compounds, but they're quite interesting. Advanced glycation end products, or AGEs. You guys heard of that? No. So basically, it's a heat-induced food toxin. It releases free radicals, so you remember those reactive oxygen species free radicals that we talked about? It releases those during formation. And foods that are high in protein and lipid content, or fat content, have the most AGEs. And the age formation depends on the temperature of the cooking. Higher temperature equals more AGEs. Method of cooking, so we know oven frying is more than deep frying, forms more than broiling, forms more than roasting, and then the duration of cooking. And one other super interesting thing about these AGEs, they contribute to inflammation, chronic disease. They also break down the collagen in your skin. Do you know what breaking down the collagen in your skin means? You age faster, you get wrinkles, yeah. Who's heard of TMAO? Okay, so I'll go over it really briefly. But what's super interesting about TMAOs involves something else I really like to talk about, which is the gut bacteria. So essentially, if you eat a food that is high in choline or phosphatidylcholine, it gets metabolized by the bacteria in your gut and by your liver into a compound called TMAO. TMAO is toxic. It's a carcinogen in your colon. It causes colon cancer. It also is inflammatory, so it causes coronary artery disease. Problems with that. So TMAO is a compound that scientists have proven comes from this choline molecule that can be a carcinogen. Top sources of choline in the American diet? Eggs and meat. Let's spend a quick minute to talk about physical activity because it is a huge deal. Many studies show the less physically active you are, the higher your risk of cancer. So those two things are very closely related. Recommendations? Well, for cancer prevention, we're looking at 30 minutes of moderate intensity physical activity 3 times a week. So that means you're walking with your friend, jogging with your friend, you can barely keep a conversation. That's moderate activity. And then vigorous physical activity, you can't keep a conversation because you're so winded with your exercise, 25 minutes 3 times a week. That's for cancer prevention recommendations. So when you look at a graph, and this is breast cancer risk, this was a meta-analysis, you can see that METs are on the bottom, they're units of activity. The more active you are, your cancer rate goes down. So I've kind of overwhelmed you, I think. We've talked about a lot. We've talked about foods that you may love to eat that may not be the best for you. What can we do? How can we move forward from this? Well, there is some encouraging news. The AICR, American Institute for Cancer Research, and the World Cancer Research Fund, they come up with a report, and this report has come out twice now. The most recent iteration was a year ago. And essentially, they talk about guidelines for cancer prevention. They also state that diet can reduce incidence of cancers by 1/3, and another third can be prevented from abolishing smoking. So along the same lines of what we've been talking about this entire time. So we have 10 recommendations for cancer prevention, and we'll go through these pretty fast. They are on the internet as well. So the number 10 is you want to be as lean as possible, so don't become obese. You don't really want to be underweight either. 2, you want to be physically active, 30 minutes every day. 3, you want to avoid sugary drinks and limit consumption of energy-dense foods. 4, you want to eat more fruits, vegetables, whole grains, and legumes. So this will be important later, but whole grains and legumes, carbs, right? 5, limit consumption of red meats and avoid processed meats. 6, if consumed at all, limit alcoholic drinks to 2 for men and 1 for women a day. 7, limit consumption of salty foods and foods processed with salt. 8, don't use supplements to protect against cancer. 9, it's best for mothers to breastfeed exclusively for 6 months and then add other liquids and foods slowly. And 10 is one of the most important of all, is if you are diagnosed with cancer, after your treatment, cancer survivors should follow the recommendations for cancer prevention. So that's those recommendations in a nutshell. Moving on. This is from a website called www.angio.org, Dr. William Lee. I recommend you guys check it out if you get a chance. Angiogenesis is what we talked about with the cancer cells getting new blood supply, new blood vessels. And what we have here in the blue are some of the known cancer drugs that we use to treat cancers. In this graph, to the right, if you are more of an angiogenesis inhibitor, that's good. Okay. When we add some other common drugs, yes, there's some that may not be chemotherapy or cancer drugs, but they happen to work against angiogenesis. But this next one is what really struck me. When we add some dietary factors, look at how powerful they are with anti-angiogenesis. So you can see tea, turmeric, lavender, red grapes, garlic, soy, those are all so high up there. They're up there with some of these chemotherapy drugs as far as inhibiting angiogenesis. So let's take some time to talk about how to starve your cancer. How can we do this with nutrition? The thing is in America, everybody thinks they're healthy. I ask my patients, so do you eat healthy? They say, oh yeah, I eat a healthy diet. And then you really dive into the weeds and you say, so what exactly did you eat? And then you find out that it's the opposite of healthy. So what is healthy, right? Well, we know eating fruits and vegetables every day is very healthy. Getting regular exercise, maintaining a healthy weight, and not smoking. What percentage of Americans do you think hit all four of those points? 3%. That's pretty sobering. So some more quiz time. How many servings of fruit and vegetables a day is recommended? It's actually only 5. How about this one? What percentage of Americans eat the recommended fruits and vegetables? So 10%. And how about this one? Americans eat an average of how many servings of fruit and vegetables a day? 1.7. And do you know what most of those fruits and vegetables are? French fries and orange juice. That's pretty sad. So what is the standard American diet, the SAD diet? Well, if you look at it, it's mostly meat, dairy, eggs, added fats, added sugar, and then highly processed grains. So with vegetables and fruits, we know there's an inverse association between vegetable and fruit consumption and cancer risk. So the more fruits and vegetables we eat, the lower our cancer risk. That's been shown time and time again in studies, especially cancers of the mouth, the pharynx, the esophagus, the lung, the stomach, and the colon and the rectum. With vegetables and fruits, what is it about them that are so cancer preventative? Is it the fact that they have vitamin E or carotene, beta carotene? I mean, why can't we just go buy a beta carotene supplement off the shelf and it'll be the same as a fruit and vegetable? It's because everything is a package. They have phytonutrients. They do have vitamins and minerals. They have something called fiber, which is really, really important. Phytates. They reduce oxidative damage to DNA, so they actually reduce the free radical formation that we're talking about. And then some of them have real specialty compounds, like glucosinolates. Anybody know where that comes from? Broccoli, cruciferous vegetables. EGCG comes from green tea. There's many, many specialty compounds that come in whole foods. So then you might ask me, well, which vegetables are the best? There's got to be some that are the best for cancer prevention, right? Well, the rule is you want to diversify your vegetables. You don't want to eat the same vegetables every day because some vegetables, tomatoes or lycopene, for example, are really, really good to prevent prostate cancer, but maybe they're not so good to prevent some other kind of cancer. So you want to cycle through your vegetables. We're going to play a little game for a second. This is an all-you-can-eat salad bar. We're going to see if we can make some good decisions. So you're at the salad bar. You are asked, well, what would you like for your base? What type of green would you like for your base? And purely from an anti-cancer standpoint, which one are you guys going to pick? You guys are good. Good job. Okay. So spinach, we know it's a huge anti-cancer agent, right? It's got activity against breast cancer, brain tumors, kidney cancer, lung cancer, pancreas and prostate cancer. It has more anti-cancer activity than all the others. Oops, though, sorry, we're out of spinach. What are you going to pick? Radicchio is number 2. So radicchio is a very, very good one as well. So you've got your radicchio, you're going through the salad bar, and you're asked, which toppings would you like? There's 31 on the menu, but you can only choose 11. Which ones do you guys want? Broccoli. Broccoli's a good one. What else? Okay, I'm hearing some really, really good suggestions here. So cabbage, that's a good one. How about garlic? Garlic is a huge cancer preventative agent. What about berries? Beans, 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 beans. Cram those in every chance you get. Green onions, curly cabbage. Brussels sprouts are there, but they're not at the top. Kale, broccoli, Brussels sprouts. Nuts are huge. So what we know from all these, and they come from 2 main families. Do we know the names of these families, all of those? So we have the cruciferous vegetables, good, and then the allium vegetables. There's a new field, and it's called nutraepigenetics. Has anybody heard of that? It's basically a field where scientists are looking at how nutrition and specific parts of plants can change the genome, can change which genes are expressed versus not. And we're learning a lot about this. So this is an example. You can see all on the bottom is all the DNA and the RNA getting transcribed and genes getting expressed. But on the top, there are all these compounds that scientists are studying that can change how your DNA is expressed. It's very exciting stuff. So we'll take a minute to talk about fiber. Fiber is one of my favorite topics. Only 6% of Americans get enough fiber in their diet. It's hard to get when you're not eating fruits and vegetables, right? So we know that dietary fiber in the instance of colorectal cancer can seriously decrease your rates. And how does it do that? Well, fiber, for one, increases your stool bulk, which is huge. So if you think of your GI tract as filtering out carcinogens, if you have more stool bulk, you're going to dilute that. And it also decreases something called transit time, meaning the time it takes from your food, from the top of your intestine to get to the toilet is much shorter. You want that. You want the carcinogens to have the shortest amount of time that they contact your colon wall. So that's a good thing. The last thing that they do is they change your gut bacteria. When the bacteria sees the fiber, they're going to actually create something called butyrate, which is a protective substance that lines your colon and protects you and is anti-inflammatory. So cruciferous vegetables, briefly, those are things like broccoli, cabbage, collards, kale, arugula, bok choy, etc. We recommend about half a cup per day, that's minimum, and they're super, super cancer preventative. And the reason why they are so preventative is because they create sulforaphane. Heard of sulforaphane? No. So sulforaphane is a very cool compound. It's created when broccoli or any cruciferous vegetable is chewed up. So sulforaphane can prevent DNA damage, and it can actually decrease the chance of cancer metastasizing. It's been shown to prevent lymphoma. It's been shown to target breast cancer stem cells, for example. It reduces the progression of prostate cancer. And then not even from a cancer standpoint, it seems to reduce inflammation. It activates your defenses against pollutants. It helps do all sorts of things. But the interesting thing about sulforaphane is you kind of have to work to get it. You can't just eat your broccoli, barely chew it, and get high amounts of sulforaphane? Sulforaphane is activated by two enzymes, myrosinase and glucosinolase, and they sit in different parts of the cell wall. So if you think of a cell walls in plants have very thick walls, very thick linings. They don't intermingle, those two enzymes. And those two enzymes have to mix in order to create sulforaphane. So what you need to do is chew for a very long time, or cut your broccoli, cut your cruciferous vegetables, let them sit so those can intermingle before you actually eat them. Or you can add something called mustard powder, which can help activate that myrosinase. That's how you can get the most from your broccoli greens. The highest amount of sulforaphane per gram is not actually from broccoli, it's from broccoli sprouts. And I don't know if any of you guys have tried broccoli sprouts. They're a little pungent, but they are so, so good for you. You can sprout them yourself. So let's talk about allium vegetables, the garlics, the onions, etc. Shallots, leeks. Talk about the history real quick. So first Olympic Games in Greece, did you guys know that the athletes chewed on garlic for endurance? And then in ancient Roman times, when they would go to war, they also chewed garlic for strength right before battle. How do they work? Many different ways. So they stop cancer initiation. Those N-nitroso compounds we talked about, they actually break them down. They stop cancer promotion. They can cause apoptosis or programmed cell death. They're antimicrobial, so they can stop the formation of H. pylori, which is one of those bacteria that cause cancer. They're a strong antioxidant, so they decrease free radical formation in our body. They decrease inflammation, just like any NSAID, so aspirin or ibuprofen would. And they also modulate your immune system. Super, super powerful. Moving on to berries, just covering all these top cancer-fighting foods. So berries also are very high antioxidants. They're one of the best fruits that you can eat. If you look at antioxidant content, blueberries are at the top, and then they decrease sequentially. So you have cranberries, blackberries, raspberries, strawberries. Recommendations are half a cup per day, fresh or frozen. You beat me to it. Thank you. I should have planted that question. So blueberries, many people think are the highest antioxidant berry, but actually gooseberries are the highest, and goji berries are up there as well. So has anybody heard of amla, or the Indian gooseberry? Yeah, so it's the most potent antioxidant known. It's from India. If you tried it, you'll know it's very bitter and grassy tasting, but it is the strongest antioxidant known. So that graph I showed you of the berries, you can see the amla is way up there in antioxidant content, and the blueberries, it just outperforms everybody. So amla berries are 75% higher than goji berries. So yes, 75% more than goji berries, 50 times more antioxidant potential than blueberries, 2.5 times more than raw acai fruit. So how does it work? Well, scientists are investigating all of these different aspects of this gooseberry. You can see the free radicals, so it scavenges free radicals, it decreases inflammation, decreases mutagenesis, etc. So it's a very promising compound. These are the compounds they isolated, so anti-cancer activities. We can see all of these are currently being researched. So we'll talk about leafy greens real quick. Leafy greens are anything, even the cruciferous, the kale, the bok choy, etc., Swiss chard. There's numerous studies, and they suggest that daily intake of green leafy vegetables are associated with lower risk of all-cause mortality. Flaxseed, I want to talk about very quick. Flaxseed is a very, very powerful antioxidant medication. It lowers the risk of colon and breast cancer. That's been shown on many studies. And it has many bioactive components. So it has a lot of fiber. It has a lot of what we call ALA, which is an omega-3 fatty acid. It has lignans. It has other phytochemicals. So we'll move on to turmeric, which is one of my favorite compounds as well. There's over 12,700 studies that are published to date on turmeric and curcumin. Curcumin is the active ingredient in turmeric. It's been researched so much. You can see all of these compounds that are in molecular pathways of cancer that are being researched. And again, the specific cancers are here. And this is just to demonstrate how much research is going on right now with all these cancers. So melanoma is a good one, gynecologic cancers, breast cancer, etc. And one more picture about all of these pathways that we're researching actively about curcumin. It's very promising. So with turmeric, you want a 1/4 teaspoon per day minimum, if you can get it on your food. So best ways to consume that, you're looking at smoothies, salads, salad dressings, curries, stir fry, nut milk. One important thing with the curcumin is if you want to increase absorption, you want to add black pepper or nuts to try to get that absorption in your body. All right, let's talk about a couple controversial things before we wrap it up. Let's talk about soy. How do we feel about soy? Just a show of hands, who thinks soy is good? Okay, and who thinks soy is bad? Okay. Who thinks soy causes breast cancer? Hard to say. Who thinks soy causes man boobs? Okay. So there's a lot of misconceptions about soy. And one of them is that it is an estrogen-like substance that can cause men to have breasts, can accelerate breast cancers, etc. That's absolutely not true. Soy is one of the healthiest foods that we can put in our body. And I just want to correct any misunderstandings that are with soy. So, soy is rich in something called phytoestrogens. So phytoestrogens are plant estrogens that they bind to the same receptors as estrogen in your body, but they have a weaker effect. So they block human estrogen in a sense. Now with soy, we have to get a little bit technical here. There's 2 estrogen receptors in our body. There's ER alpha and there's ER beta. ER alpha is the one that our estrogen, our body's estrogen, likes to bind to. ER beta is the one that the soy, the phytoestrogens, like to bind to. When we have the ER beta receptors taken up, the phytoestrogens help inhibit mammary cell growth. So they actually slow down growth, and it actually inhibits the ER alpha receptors. So they talk to each other, they interact. So the effect of soy phytoestrogens is going to depend on your ratio of ER alpha to ER beta receptors. Soy can be likened to a drug we use to treat breast cancer called a SERM, a selective estrogen receptor modifier. So when we have patients with breast cancer, many times they're put on this pill that they take every day that blocks the ER alpha receptors in their body. Soy kind of does the same thing. So it is good. And there's many studies showing that it improves survival in women with breast cancer. So we have to talk about soy as a whole though, right? We don't want to talk about processed soy, soy protein isolates. When I talk about soy, I'm talking about whole food soy, which I consider edamame, tofu, tempeh, natto, that type of stuff. So with soy, eating 1 to 2 servings whole soy every day can reduce your breast cancer risk and your risk of recurrence by 25%. But we do have to understand this is not processed soy, like I said, and also if you have an option, get the non-GMO soy. Make sense? A little bit? It's kind of technical, but soy is an interesting one. Let's take a second to talk about this fad called the keto diet. You guys heard of it? Yeah, so it seems like everybody's doing that. I saw an Instagram post today about keto diet and somebody posting basically the picture perfect keto diet, and it was chicken skin alone fried with bacon or something like that. And touting the health effects of that is interesting. So in any case, what about the history? So the keto diet has been around for a while, 1921. This gentleman, Dr. R.M. Wilder, he was a Mayo doctor, and he started exploring it for treatment of kids that had epilepsy that was refractory to treatment, to conventional treatment. So he put these kids on a keto diet and he saw success. This was actually quite popular till about the 1950s. and then it decreased in popularity, and then in the mid-1990s, for some reason it's back in vogue. Anybody know what the original keto diet is? It's fasting. So the keto diet, what it is, and the physiology behind it, is your body switches fuel sources. So your body starts out, let's say you have breakfast, your body starts out living off of glucose. That runs all of our organs. Once your glucose runs out, your body creates glucose by gluconeogenesis. So your liver actually creates glucose. It's a beautiful thing. That happens 24 to 48 hours. And once your glycogen stores are gone, you have to switch. Your body starts running off of ketones, which is a fatty ester. Your brain can run off ketones. All of your body organs can run off of ketones. So that happens typically when you're water fasting. After 2 to 3 days, you start running off of ketones. We know that there's benefits to water fasting, especially when it comes to inflammation. Some people would tout even to cancer. So can this translate over to the keto diet that we're calling the keto diet today? Well, what is the keto diet? If you look here, the keto diet, 2% carbohydrates out of your entire diet. That's not much. 90% fat, 8% protein. How does that compare to the Atkins diet in the middle? Little less fat, a little more protein, that's about it. And then how does it compare to the standard American diet? Well, the standard American diet might not be the best thing to compare it to, right? So keto food pyramid. And I will start by saying there's a lot of good things about the keto diet. They cut out a lot of the processed food. They cut out a lot of the packaged stuff. They're cutting out milk, they're cutting out sugar, etc. It seems like it's fairly wholesome. But then when you look at the bottom of the food pyramid here, it's all meat, dairy, eggs, and oil. That's quite concerning. Remember how we talked about meat, dairy, eggs, and IGF-1? That's a concern. That's not even mentioning all the heart problems, vascular disease, etc. that can come from eating this high cholesterol food. But despite that, there is ongoing research, and we just don't know enough about it yet. So the keto diet, scientists are looking at treating gliomas, which is a brain tumor that's very malignant, colon cancers, stomach cancers, prostate cancer. Actually, 72% of the animal studies showed that there was a reduction in tumor burden with what they're calling the keto diet. So it's an interesting thing. But the question becomes, what are the long-term effects? We don't know. Traditionally, humans, when they are on keto or starving, it's not forever. It's a limited amount of time, and then they go back to refeeding. This keto thing, people are trying months on end to be in a ketotic state. I will say there is such a thing as a vegan ketogenic diet. It can be done. For people that are curious about that, looks kind of like this. So you are keeping avocados, coconut oil, seeds, high-fat foods, again, concerned with the high-fat, high-inflammatory status, and you're cutting out all of these carbs. I don't know that that's the best thing. But again, it's new, and scientists are studying this. So what about the ketogenic diet is concerning? Well, this is a paper that came out showing there's acute problem, so you can have GI discomfort. People talk about a keto fog or a keto brain, so to speak. You're lethargic. When you look at chronic effects, though, you start looking at the concerns, the elevated LDL, so the heart disease, bone mineral loss, kidney stones is a big one. This was in the paper. I don't know why there's a typo, but it's decreased IGF-1, which we like when we're looking at cancer and renal damage. So again, very, very new stuff. We really don't know. But what we do know is there's been a few studies on low-carb diets, not necessarily keto diets, but low-carb diets. And this was a big study just published showing there's a huge risk of all-cause mortality with a low-carb diet. So basically, If you eat a low-carb diet, you are 30% more likely to die from any cause compared to somebody who does not eat a low-carb diet. And this is a huge study of thousands and thousands of people, over 270,000 people. So that's the keto diet in a nutshell. Make sense? Okay. So let's wrap it up real quick. How to starve your cancer. Key points, things I want you guys to take home from this talk. Lifestyle changes can dramatically decrease your risk of cancer. So not only diet, but physical activity, exercise, taking care of yourself can dramatically decrease your risk of cancer. Fruit and vegetable intake is inversely proportional to cancer development. High fruits, vegetables, low risk of cancer. That's a huge take-home message. And then lastly, physical activity adds on. It's additive to anything we're doing with the diet. So we want to make sure we're up, we're active, we're getting out there. And that's what I have for you guys. Thank you guys so much for your attention. I really appreciate it.